Hey everyone. In today's digital world, computers are everywhere, right? From our phones to supercomputers, they all work based on the same basic rules. These rules are called computer architecture. Basically, computer architecture is like designing and organizing a computer system. We want it to be fast, efficient, and not too expensive. For A-level students, learning about computer architecture is super important. It's like understanding the foundation of how computers work. This knowledge is helpful for anyone interested in computers, software, or electrical engineering. It's also good for anyone who wants to understand technology better. Think of a busy city with roads, bridges, and buildings. Computer architecture is like the city's plan. It shows how everything connects. Just like a city's plan affects traffic, computer architecture affects how data moves inside a computer. By learning these rules, you'll understand what makes a computer fast or slow, what it can and can't do. This helps you choose the right hardware, improve software, and fix problems. Every computer has a central processing unit, or CPU. It's like the brain of the computer. The CPU runs instructions from programs, does math, and controls how data moves between parts of the computer. Imagine the CPU as a conductor of an orchestra. It reads the music, instructions, and tells the orchestra, other computer parts, what to do. The CPU has a few main parts. The control unit is like the CPU's own brain. It gets instructions, figures out what they mean, and tells other parts what to do. The arithmetic logic unit, or ALU, does math and logic like adding, subtracting, and comparing things. Registers are like tiny, super-fast storage areas inside the CPU. They hold the data the CPU is currently working with. How fast a CPU is measured in clock speed, which is in gigahertz, GHz. Higher GHz means faster processing. Also, many CPUs now have multiple cores. This means they can do many things at once, making them even faster. To do its job, the CPU uses instructions like a chef follows a recipe. These instructions are called the instruction set architecture, or ISA. They tell the CPU what basic actions it can do. Each instruction is a code that means something specific, like get data from memory, or add these two numbers. The ISA is like a language between the software and the hardware. It lets programmers write instructions that the CPU understands. Different CPUs have different ISAs, each with its pros and cons. Think of an ISA like Lego blocks. Programmers use these blocks, instructions, to build complex programs. The ISA affects how fast, how power-hungry, and how expensive a computer is. Some ISAs have fewer, simpler instructions, or ISI. These are good for saving power in mobile devices. Others have lots of complex instructions, CISC, which are good for powerful desktop computers and servers. Just like a chef needs a workspace, the CPU needs memory to store data and instructions. Computer memory is organized in levels, from superfast to slower, from small to large, and from expensive to cheaper. First, we have registers right inside the CPU. They're superfast but very small. Then there's cache memory, which is like a quick access area between the CPU and main memory. It's faster than main memory, but slower than registers. It holds stuff the CPU uses a lot. Main memory, or RAM, is the CPU's main workspace. It's bigger than cache, but slower. It holds the operating system, programs, and data you're using. Finally, there's secondary storage, like hard drives, HDDs, and solid-state drives, SSDs. This is for long-term storage of things you're not using right now. It's much slower than main memory, but can hold much more. Input-output, or I/O, lets a computer talk to the outside world. Input devices like keyboards, mice, and cameras let us put information into the computer. Output devices like screens, printers, and speakers let the computer show us information. Think of I/O devices as the computer's sensors and ways of communicating. I/O devices connect to the CPU and memory through a bus, which is like a data highway. I/O can sometimes slow things down because it's often slower than the CPU and memory, so computers use tricks like buffering, caching, and DMA, direct memory access, to make I/O faster.